All right, let's explore another variation of the same problem as before. This time, we are going to be transforming. So we have 3 to the x plus 5 minus 2. So we're translating that left 5 and down 2 from the parent function 3 to the x power. So we want to graph that first to see what that looks like. So you do y equals 3 raised to the, and then use parentheses for your exponent in Desmos, x plus 5, close it up, right arrow, minus 2. You can copy and paste this too. So if you do Control C, Control V, you can do that too. And for some reason, it lets you do it without parentheses that way. But if you need to edit it, you have to put those parentheses back in. So I always, as a general rule, put those in there. All right, so let's take a look at the graph. We have 3 questions for that graph. What is the domain? Well, like the question before, the domain for exponential functions, they will still keep going to the right. You can plug in any value of x, even though it looks like it stops at a certain point, x values will keep going to the right as much as you want them. So more zeros I add to those, the higher that x value goes. Now it's ridiculously large numbers there, but the domain is going to be all real numbers. All real numbers. Now the range is the y values, and it does stop at a certain point, but it's not 0, right? It dips below 0. So that smallest y value, it approaches but never actually touches -2. You see how it gets closer and closer to -2. Eventually the graph rounds it off, but as x gets in the negatives more, y approaches -2 but never touches it. So we'd say y is greater than -2 because it goes up. So y is greater than -2. And the asymptote, again, is a horizontal asymptote, and that's going to be y equals -2. Because if you graph y equals -2, you can see that you got a flat line that this graph never touches or crosses over. Now let's compare its inverse. This is the inverse of that function. So you originally had 3 to the x plus 5 minus 2. Then you have log base 3 of x plus 2 minus 5. Notice first what happened to the numbers. They switched places. So the 2 got put in with the x and the log, and the sign switched. And the 5 got put in at the end, and the sign switched. That's inverses have opposite signs, so that makes sense, hopefully. Let's graph that. Log base 3, x plus 2, minus 5. All right, so the domain, you can't plug in every number to the logarithm. You can't plug in a number that gives you a negative. So if I plug in -2, it's going to say undefined. If I plug in -3, that's undefined. But if I plug in 1, or -1, that'll give me inside the parentheses -1. So that gives me a number I can use. So in general, anything that is going to be greater than 2, I'm allowed to plug in, but I can't -2. I'm allowed to plug anything greater than -2, but I cannot plug in -2 itself. So you say x is greater than -2 or -2 to infinity. The range, just like the previous problem, there is an unlimited y value if I make that x-axis go higher and higher, that y value will still go higher. And that'll always be true. So the range is going to be, because it goes down and up forever, all real numbers, -infinity to infinity. And the asymptote, this one's a vertical asymptote. It approaches a vertical line. And that vertical line in this situation is going to be x equals 2, -2. It'll never actually become -2. So the asymptote is x equals -2. And we can graph that, x equals -2. And it'll show you a vertical line right there that graph never crosses over. Again, it's trying to very hard distance itself from that -2. So it'll just kind of keep approaching it, get closer and closer and go downward. So let's verify their inverses. And as you can see, they are reflections over the line, y equals x. And take a look at those intercepts. You see how they're flipped. So that's kind of a verifying aspect of it. And that answers the question. Thank you.